Hi everyone, a very good morning. So today's topic of discussion is rolling motion. All of us know rolling is a subtopic of rotational dynamics and we have already studied rotational dynamics. So we are going to study rolling motion today and I'll be explaining what exactly it is. Okay. So first of all, understand what is the definition of rolling motion. We will go by the definition and then we will elaborate, we will do numericals, we will conceptualize it and everything. So first of all, let us understand the definition of rolling motion. A rolling motion is defined as a motion which is combination of translation and rotation, commonly as of an axially symmetric body, and with respect to surface, if ideal condition exists, it does not slide. Slightly complex, yeah. Rolling motion is a bit complex, this is one of the most difficult and one of the most complex part of rotation. So definition is also defined in a very complex way. So we will be explaining it in the board and we will take each and every part of the definition and I will be explaining what exactly it is. So first of all, I mentioned combined rotation and translation. Okay. Second part that I told, with respect to a surface. Third part is commonly of an axially symmetric body. And the fourth part is if ideal condition exists, there is no sliding. Now we understand all these four terms one by one. Okay. First one is combined rotation and translation. So as we studied rotational motion, first we will differentiate between rotation and translation. So if a marker goes like this, something like this is a translation motion. But a marker goes like this. This rotates like this kind of motion. So in this case, center of mass is translating, moving, as well as the marker is rotating. The whole body is rotating. So this is combined rotation and translation. So this is the first condition for a rolling. It should be combined rotation and translation. Like if I throw this marker like this. So this is only translation motion with respect to center of mass. And now if I throw something like this, so see this is rotating as well as translation. So this consists of both the motion, translation and rotation. So first condition is satisfied for this marker. Now let us look at the second condition with respect to surface. When I threw this marker, it was flying in the air. There was no surface, right? So if there is no surface, this condition is not satisfied because the definition is with respect to a surface. But if I move this marker on my palm, see something like this. What is happening there? The center of mass is moving, translating, and the marker is rotating. The angle is changing. So this is combined rotation and translation, as well as there is a surface. Surface is my palm. So this is rotating on my surface. This is my palm. So second condition is satisfied. Now look at the third condition, commonly of an axially symmetric body. See, this is not a condition like there should be always axially symmetric body for rolling, but commonly defining rolling in terms of these kind of objects is a kind of meaningless. We do not study rolling in terms of a axially non-symmetric bodies. Normally some spherical body, cylindrical body, conical body, which are normally axially symmetric. So look at this marker. The axis of this marker is this, the perpendicular to the plane. And about this axis, if you look from this axis, the whole marker is symmetric. So the third condition is also satisfied by this marker. And now the remaining one condition is if ideal condition exists, there is no sliding. Sliding means when we ride a bike and when we apply the brakes, the bike skids on the road. There is sliding, like this is something like this. It does not properly roll. But when you gently ride your bike, it gently roll like the wheel rotates as well as the center of mass translates. But when we apply the brake, the center of mass, like this is the bike. Like this is the bike. So when you apply the brake, the center of mass translates. But look at the bottom part of the wheel. This is skids on the road. There is no rolling. There is no rotation. So there is skidding. So if ideal condition exists, there is no sliding. And when there is no sliding, that is known as pure rolling. So this is the situation of ideal condition, and these are the 4 conditions for rolling. So not in all the situation, in fact ideal condition is never, there is never any ideal condition, nothing is ideal in this world. So even if you ride your bike, it ideally does not roll, it does not perform pure rolling on the road. In fact, there is a very small amount of sliding that we cannot observe practically. So we'll understand these things slowly, okay? Let us go ahead, and now we should apply this definition in a particular example, and we will see what are the mathematical conditions that govern rolling motion. Okay. So let us take the example of a wheel of a bike. Let us take an example. This is a wheel of a bike. So if you look at this wheel, first of all, this is axially symmetric body. See, this is the axis, then this is the axially symmetric body. From the axis, you can observe the whole body is symmetric. Now there should be a surface for the rolling. So bike rides on the road. Road is the surface. This is my road. This is the wheel. Okay? Its radius is given as r. Mass of the wheel is given as m. Okay? Now, so first thing is combined rotation and translation. So bike, assume the bike is translating with velocity of center of mass as v, and it is rotating with an angular velocity omega. So combined rotation and translation. Second thing is with respect to surface, that means there is a road. Third thing was axially symmetric body, and now remember the fourth point, which was if ideal conditions exist, there is no sliding. Okay. So we will fulfill that condition. How there will be no sliding? Okay. Before going into sliding, I will explain you 2 things. There are 2 types of surface. Types of surface in rolling. First one is static. Static surface. That means surface itself is not moving. And second one is moving surface. Moving surface, that means surface itself has a velocity. For example, static surface, that means on earth. On earth, when a bike goes, then there is no motion. Like we observe, earth is not moving, so earth is a kind of static surface. So that is the example of first type of surface. And moving surface, like see, here it is my palm and the marker is rolling, so my hand are also moving back or front, something like this. So surface is moving. There are 2 kinds of surface. Dealing with moving surface is a bit of complexity. So first we will deal with static surface, and later on we will deal with moving surface. So first let us focus on the static surface. So now onwards I am assuming the surface to be static unless I do not mention it. So surface is static, right? Surface is static. That means surface is at rest. That means velocity of surface is 0. Okay. Now we will fulfill the condition. So what does the condition say? The body is not sliding with respect to surface. Body is not sliding. When does sliding occur? In friction you would have studied when there is relative motion. When there is relative motion between 2 bodies, then there is sliding between the bodies. If there is no relative motion between 2 bodies, there is no sliding. That means, see, the point of contact, this is the point of contact. Point of contact, where the surface and the body is getting in contact with each other. It does not have to slide. It does not have to slide with respect to surface. For what? For what? For pure rolling. For pure rolling, right? So it does not have to slide. That means there is no relative velocity between surface and this body. As similar as we studied in friction, if there are two blocks, this is block 1 and this is block 2, if both moves with same velocity, there is no friction between them. If there is no relative velocity, there is no sliding. But if the velocities are different, like V1, V2, there is a sliding that occurs between these two bodies. That means both these surface should move, both these bodies, like body and the surface, should move with same velocity. The relative velocity should be 0. Understood? Once again I am telling there is no sliding. No sliding means both should have same velocity, which means the relative velocity between surface and the body, the rolling body, should be 0. That means velocity of body with this velocity of what? Like this, let's say this is point P, let us say this is point P. So if there is no sliding at this point, that means velocity of point P, not the whole body, velocity of point P with respect to surface should be 0. That means velocity of point P with respect to surface should be 0. Velocity of point P with respect to surface should be 0, and this is the condition for pure rolling. This is not at all difficult. First was translation and rotation, second was with respect to surface, third thing was axial symmetric body, and the fourth condition there is no sliding, and no sliding condition is the velocity of point P with respect to surface should be 0. So this is the no sliding condition. Okay, so no sliding condition. Now we will go ahead. First of all, I wanted to make you very clear about this point, because this is the very basic of rolling motion. If you don't get it, you won't get it, further. Like it will be difficult, it will be more complex. So this is the very basic. Velocity of point P with respect to surface should be 0. This is the first condition. Now we will go for the second condition. What is the second condition? A body with velocity, it may have some acceleration and it also may have some angular acceleration alpha. So as same as we did for velocity, therefore no sliding. Similarly, the acceleration of this point with respect to surface should be 0. For what? For no sliding. So second condition is acceleration of point with respect to surface should be 0. For no sliding. So both these conditions leads to no sliding, and that means simply pure rolling. Okay. Now we'll go ahead and derive some mathematical equation, and we will see what happens in rolling. What is governed the motion of rolling, and some other details we will look into. Okay. Okay, fine. Put it down. Now, as we discussed earlier, we have assumed the surface to be static. Static surface. Static surface means surface is not moving, surface is at rest. That means velocity of surface is 0. And what condition we have seen? Static surface, velocity of surface is 0, as well as acceleration of surface is 0. So the first condition that we derived there was velocity of point P with respect to surface is 0. This was condition 1. That means velocity of point P minus velocity of surface is 0. Relative motion concept. Velocity of point P, Vp minus Vs will be equal to 0. That means Vp equal to Vs, and as we know the surface is static, so Vs is 0. That means velocity of point P is 0. Second condition was acceleration of point P with respect to surface should be 0, and using the relative velocity and relative acceleration concept, acceleration AP minus AS equal to 0, and that simply means AP should be equal to AS. and as we know, for a static surface AS equal to 0, which means AP equal to 0. So these are the two conditions when we deal with a static surface. The dynamic surface will be dealing in later, but currently we are dealing with static surface. So these are the two conditions. Okay. Fine. Now this is our body and this is the surface. It has acceleration A, angular acceleration alpha. This is velocity V and angular velocity omega. So first condition is velocity of P equal to velocity of S equal to 0. This is our point P. So first condition is Vp equal to 0. Now we are going to find out the velocity of point P. How will we be finding? So see, this is the center of mass. And when a body is combined rotation and translation, all of us have already studied how to find the velocity of a point P. So see, if this is the center of mass and this is the body, and the whole body is moving with omega and center of mass is moving with V translation velocity. So let us assume this point to be point P. So velocity of this point P is written as V vector in this direction and R omega, that is this, in this direction. So this is the dV vector and this is R omega vector, and that is the complete velocity of that point. Similarly, we are going to find out something like this. So for point P, look at point P. Point P is connected like this. So this is the radius vector of point P with respect to center of mass, and this is the velocity V of center of mass. So what will be the velocity of point P? So first of all, velocity of point P will be equal to VCM, that is V I cap in x direction. Look at the direction of V vector, that is in x direction, that is I cap, velocity of center of mass. And another term that comes due to rotational velocity, that is R into omega. And R into omega, so this is the omega and this is the radius. So R omega will be this direction. Look, R omega. So this is the direction of velocity. This is the value of R omega. So V I cap plus R omega, and the direction is minus I cap. Correct? Fine. Now I'll go ahead. So this is V I cap minus R omega I cap. And this is nothing but equal to V minus R omega I cap. And do you remember, in the first condition we derived that Vp should be equal to 0 for no sliding. That means the whole term should be equal to 0. And the only condition for this term to be equal to 0 is V minus R omega is 0. That is V equal to R omega. This is the condition for pure rolling. For which kind of surface? Static surface. The surface which are at rest. This is a very famous equation, a very well-known equation in rolling chapter. So you must remember it and keep it in mind. You just need not to remember it. Just keep it in mind. Keep the concept. What is the condition of no sliding? There should not be relative motion between surface and the body. So no relative motion, Vp is 0. That means Vp minus V is 0. That means Vp equal to V is 0. So Vp is 0. And we got the condition V equal to R omega. So this is the first condition. This is the first condition. The second condition for rolling is that we derived here is the value of AP is 0. So AP is equal to 0. Now we will write down the acceleration of point P. So AP vector is equal to, look at this equation. A is the acceleration of center of mass in x direction. So one acceleration will come there, A I cap. Similarly like V, so similarly like A in this direction. And there is an alpha 2. Alpha is angular acceleration. So due to this angular acceleration, there will be a translational acceleration, and that will be equal to R alpha. And what is the direction? Minus I cap. Minus I cap. That means this is equal to A I cap minus R alpha I cap, which means equal to A minus R alpha I cap, which is equal to 0. That we have derived equal to 0. That simply means A equal to R omega. And this is the second condition for rolling. There is nothing much in rolling than this. But yes, people are really confused because this is the very starting point and the starting point is not clear. So if you are clear with this, not a single question of rolling can keep you in trouble. So just have these two equations and the basic concept behind these two equations in your mind, and you will never be, you will never hesitate to solve a problem for rolling. So now we will go ahead, and these are the two conditions for the rolling, and we will be looking at one example. Okay, so just wrote it down. Now I am rubbing this. So we will be going to an example. So I'm asking a question from you. This is a well, and this is the surface. So the well is going with a velocity v equal to 10 meter per second, and its angular velocity omega is equal to 5 radian per second. Its radius is r equal to 1 meter. Okay. So my first question is this body in pure rolling? How will we check? So for pure rolling and for a static surface, the first condition is v equal to r omega. No acceleration information is given, so we are not going into depth on the acceleration equation. Just velocity and omega is given. So we'll first check is v equal to r omega satisfied for this body. So v equal to r omega, the value of v is equal to 10 and equal to r is 1 into 5. 10 not equal to 5. So this body is not in pure rolling. Not in pure rolling. Now what will happen? This surface is rough. This surface is rough. Okay. So when there is no pure rolling, this surface would like it to perform the pure rolling. This surface would like it to perform the pure rolling. So what will this surface do? This will exert a friction. This will exert a friction. So due to applying the friction, let us assume the friction is acting in this direction. Let us assume this is the direction of friction. What will happen? Due to this friction, there is an acceleration in negative x direction and the velocity will decrease. And due to this friction, a torque is in this direction, so omega will increase. So now currently omega is 5, v is 10. So v will be less than 10 and omega will be greater than 5. And there will be a condition, we will reach a condition where v will be equal to r omega, and it will start performing pure rolling. So this is the way we approach the problem. So first of all, we will look at this whether it is in pure rolling or not. So currently in this situation, this body is not in pure rolling. Now you will see, okay, then what can we do? So we will apply a friction. Friction will reduce the velocity here and increase the omega here, and there will reach a condition where friction will completely equate v equal to r omega due to friction. Friction will make this body to roll, and v will equal to r omega condition will be reached, and it will be the condition for pure rolling. It will start pure rolling, and this is all the way we approach a pure rolling. One more very important thing that I would like you to know, and that is very important and very basic. So we studied that there is no sliding with respect to surface. There is no sliding with respect to surface. That means this point, the velocity of point P with respect to surface is 0. Velocity of point P with respect to surface is 0. No sliding in pure rolling. No sliding in pure rolling. And we know when there is no sliding, there is no kinetic friction. Only static friction can act. If there are two blocks, if this is block 1 and this is block 2, if they have same velocity and if there is no relative motion, there will be a static friction, not the kinetic friction. So in pure rolling, static friction acts at the point of contact. So this is all the very basic concepts of rolling, and we will discussing the remaining part, and we will doing more problems later. Okay, so all the best, have a good day to all of you. Thank you.